Hello and welcome to another revision video. Today we're looking at the higher tier revision workbook for Edexcel, and we're looking at the aspect of problem solving. So problem solving practice 1 for geometry and measures, which is topic 108 in the workbook. Okay, so question 1. The radius of a base of a cone is x centimeters and its vertical height is h centimeters. The radius of a sphere is x centimeters. The volume of the cone and the volume of the sphere are equal. Show that the height h is 4 times the radius. Okay, so for this we're going to look at the two formulas. So the volume of a cone is pi r squared h divided by 3. And then we're using x instead of the radius, so pi times by x squared times by h divided by 3. Okay, and the volume of the sphere is 4/3 pi r cubed, which is in this case 4/3 pi times by x cubed. Okay, so we're told that these two things are equal. We're going to be able to cancel lots out. I'm going to write the volume of the sphere first of all, so I'm going to write it slightly differently. 4 pi x cubed divided by 3, and I'm going to say that that's equal to pi times x squared h divided by 3. Divided by 3. I'm going to be able to cancel that down now. So I can cancel divide by 3. I can cancel the pi's out, and I can cancel the x squared by the cubed. So I'm just left with 4x is equal to h. So that shows that the height is 4 times the radius. So h is equal to 4x. Okay, question 2. A rescue helicopter is stationed at a point X. An emergency call is received and the helicopter flies 16 kilometers on a bearing of 40 degrees to point Y. A second emergency call is received and the helicopter then flies 30 kilometers on a bearing of 115 degrees to arrive at point Z. The helicopter flies back to point X. Work out the distance that the helicopter has to fly from point Z to point X. Giving your answer correct to 3 significant figures, so we're going to be using calculator for this. I'm going to start by drawing a sketch. So helicopter is stationed at point X. It receives an emergency call, so 16 kilometers on a bearing of 40 degrees. So if I mark that as north, and then we're looking at a very rough sketch, so I'm going to say that that's a bearing of 40, and I'm travelling for 16 kilometers to point Y. A second emergency call, 30 kilometers on a bearing of 115. So 115, so again, let's kind of mark it. So 115, that I'm going to say is something like that. And then the question actually asks us to work out, doesn't ask for a bearing, just asks for the distance. Okay, so we're going to be using a bit of an advanced trick here. What I'm going to do is I'm going to say that that angle there would be 40. And I'm going to say that that angle there, if that's 115, that angle there would be 180 minus 115, so that's going to be 65. The total angle here is going to be 105. I'm just going to obviously bring my calculator in and double check my calculations there. Right. Okay, so 180 minus 115 is 65, and then plus 40 is 105. Okay, so now we've got, we can use the fact that a squared is going to be equal to b squared plus c squared minus 2bc cos a. Right, and then I'm going to substitute in my values. So let's give this a letter. We'll use lowercase x. So x squared is going to be equal to 16 squared plus 30 squared minus 2 times 30. I've done that the opposite way around, but it doesn't really matter. Times by cos of 105. Okay, so 16 squared plus 30 squared minus 2 times 16 times 30 times by cos 105. That's my value of x squared, so 1404.466 dot dot dot. So x is going to be equal to the square root of that. So we're looking at 37.4762 dot dot dot. So to three significant figures, that's going to be 37.5. Okay, part B. Work out the bearing of which the helicopter has to fly to point Z, has to fly from point Z to point X, giving your answer to as a three-figure bearing. Okay, so the angle that we actually want then, the angle that we actually want is this angle here. So it's not set up nicely. So I'm going to be using the sine rule, but my slight issue is I'm not certain that this is right. I am certain it's right, but I don't like to assume that it's right for my part B. So what I'm actually going to do is I'm going to work out this angle here, and then say that that angle and that angle would be supplementary angles. So that would give me that angle, and in doing that I don't need to use x, because I can say that sine of let's call it sine of I need another letter, x, y, z we've already used. Let's use w. So sine of w over 30 is going to be equal to, I'm still using x. Can't avoid it really, can I? So I'm going to still stick with that method though, I think. So I'm going to say the sine of 105 over x. So the sine of w, well, no, I'm going to go straight to, the sine of w is going to be equal to sine of 105 over x times by 30. So w is going to be equal to the inverse sine of that, so I'm going to go shift sine, and then I'm going for a fraction, and I want to go sine of 105 divided by my value for x, which is my last answer, and I'm going to times that by 30. So that's definitely not right, because I've not done the inverse there. Okay, so let's adjust that. That was quite bad of me. Shift sine. Then I'm going to have to put my value in for my answer, which I don't like doing. So I'll go as accurate as we can. 37.4762. So we get 50.644. 9 dot dot dot. So that's the size of W. So the size of this angle would be 180 minus it. So I'm going to do my bearing is going to be, so Z is going to be equal to 180 minus W. That's going to actually be the bearing. If I call that Z, that's not the bearing yet. So 180 minus my answer is going to be 129.355, and I actually need to take that away from 360 to give it as a bearing. So 360 minus Z is going to be equal to 230.6 ... So I would go 231